Hi everyone. Given A comma B is related to C comma D, the ordered pair, if and only if AD equals BC, show that R forms an equivalence relation on R times R. So the domain and the codomain. And we're going to find the equivalence class that contains 1 comma 2 and describe the partition that R creates on R squared. So let's get started. The first thing we have to do is show that R forms an equivalence relation. So we have to show that's reflexive, symmetric, and transitive. So our question is, if we take this, we have A comma B, and we're going to write, is it related to A comma B? That would mean that AB equals BA, according to our definition, and that's true. So it's reflexive. All right. Now let's show some symmetry. So we have A comma B is related to C comma D. Then we know that AD equals BC. All right. And we can also write this as BC equals AD. Okay. Therefore, we can also write CB equals DA. Therefore, CD, and we're reversing that, is related to A comma B. Hence, R is symmetric. So that satisfies that. So this is reflexive, and this is symmetric. All right, transitive. For transitive, we're going to do A comma B is related to C comma D. Now we have to make up another one to do transitive. So we're going to do C comma D must be related to some E comma F. So we want to show that AB is related to EF. So here we go. We're going to get AD for this one. This equals AD equals BC. And for this one, we have CF equals DC. So therefore, we have AD times CF equals BC times DE. Remember, we're doing Cartesian product here. All right. And then that means that AF equals BE. These two are the same. All right. Therefore, AB is related to EF. So hence R is transitive. All right. To find the required equivalence classes, we need to consider a general point, XY, and put it with our 1 comma 2. So what we're going to do is say that some XY is related to 1 comma 2. And therefore, given our formula here, that means 2x equals y. Now, just looking at that, this represents a straight line through the origin. So you could write it y equals 2x. Straight line through the origin with the slope of 2. Hence, the equivalence class is the set of all coordinate points that lie on the line. So for the equivalence class, it's all ordered pairs, all points that lie on this line. So for example, when x is 2, y would be 4. When x is 3, y would be 6, and so forth. That would be your equivalence classes. All right. Now we have describe the partition that R creates on our Cartesian product. R partitions R times R into an infinite number of equivalence classes. Okay, so this one we just used an example 1, 2. But each class consists of coordinate points that lie on a straight line through the origin. So if we had changed this, we would have to say 1, 3. We would have gotten another equivalence class, and it would have been partitioned as such. Or if we had a 3, 1. So basically, it has an infinite number of equivalence classes. That's it. Thank you. Have a nice day. Bye-bye.